Hello. A brief introduction before I actually get to the more actual content part of this video. The last couple of years, I've been working on an internet search engine. It started during the COVID years, back when we all had a lot of time on our hands, and some spent it well and others didn't. I misspent the time making an internet search engine for fun. Originally, basically as a meme, I was targeting Raspberry Pi based servers. So I had like 4 Raspberry Pis running this, and I was indexing like I think it was 200,000 documents or something. But obviously you're going to grow out of Raspberry Pis. So I moved it to a PC instead, and now I'm indexing. I think it's currently like 70 million documents. I've had it at 106 at some point. And it's obviously fairly basic search engine, but that aside, I'm actually doing this full time nowadays. So and I mean it's a search engine, so you just type something and then you get some results, and the logic is fairly crude and so on. But that's just fun, because that means I have work to do, and search engine programming is incredibly fun, and there's a lot of breadth to the amount of problems you get to face. So what's the point of this video? I basically just want to record myself working on it, because that's the sort of content I like. And I think whether you're making music or a search engine or a YouTube video, the only way to produce something that's actually really good is to look to your own tastes, because you can guess what other people are going to like, and you're rarely going to be correct, but you know for certain what you yourself like, and so you can aim a lot more accurately for that mark. And while, like, obviously not everyone is going to love what you do, that's fine, because I mean, as long as you're literally not the only person in the world who loves this, you're going to find an audience. Yeah, but to what I wanted to do. I think actually we're going to go to the Git repository, because I have a diagram of the system here. And there's a lot of services, and there's a lot of processes and so on. But what we're looking at today is the converter process, which is it's a process that's in between the crawler and the loader, and the crawler is the piece of code that downloads websites. It doesn't have a lot of like logic. It just basically goes through a list of domains and downloads their content and saves it on disk. The next step is the converter, which will analyze all these HTML files and so on, and extract keywords, and it will figure out some metadata, like what's the title of this website, does it link anywhere, whatever, does it have ads, and that's again saved onto disk, and then the loader process will read these files one by one and insert them into the link database, and feed it to the index so that it's eventually searchable. And I actually had I made a bit of a plan for today. We're looking at the converter, and I looked at this code yesterday, and I found that it's keeping some stuff in memory in a way that's not really necessary. It's loading stuff that should be written to disk into a list, and then feeding it into a subsequent step that's actually writing it to disk. And this isn't great. This process is fairly memory hungry, and we want to keep it as slim as possible. I have like some some vision that this system is supposed to be able to run even on relatively weak hardware, and that's in general a great way of building performance software. And the fact that I originally targeted the Raspberry Pis is a big reason why I'm able to do so much with a PC. Because if you write inefficient code on a Raspberry Pi, you will be immediately made aware of this because it will take forever. And there's a second problem with this piece of code as well, and that's that it's using a weird class called ParallelPipe that I wrote a long time ago to try to generalize workflows that start by reading stuff from disk and then fanning out to do stuff that's CPU bound, and then either sending it off on network or writing it down to disk again. And this is fairly common. I find myself doing this a lot. So I wanted to basically solve the problem so I don't have to find solutions for it over and over again. But the solution wasn't actually all that great, and it's a bit jank. So I want to replace it with something that's more like the way you're supposed to do it. And that is to use a thread pool executor. And maybe I should have mentioned this, but we're coding in Java, and the reason for this is that I'm fairly productive in Java, and yeah, that's the end of the reason. Java haters can join me in the comments. So I went and looked at another piece of code that actually does this correctly, and basically just copied this piece, these pieces, so we can use them later and not have to do a bunch of research while we're coding. Yeah. So let's look at the code. Here we have the function we're going to be refactoring a bit, and this is the ParallelPipe, and as I mentioned, it's doing some stuff I don't want it to do. This compile method is so it's accumulating a list of instructions, and this design is using essentially a visitor pattern to allow the converter to program the workflow within the loader. So it's writing down instructions first to run the code that's load process domains, and then it's doing some other stuff and adding more instructions, and then the loader will basically do an invoke a method that matches this record. But we want to get rid of this list and basically feed this into something else. But I think that will be part 2 of this problem, because the reason we're sticking it into a list is because we need to write it to this processing instructions bit that goes on to the onReceive method later here. And the reason we have different methods here is because this codification of the workflow read, process, write. And it forces us to do this. What we want to do is basically have like write or something, have this method write instructions to disk or something. But I think we will get rid of the ParallelPipe first, and that will let us join this logic with this logic. So let's grab this pool creation thing, and we can actually have this within this method, because this convert method is only invoked once in this process. So we don't actually need to have anything fancy. And I think the number of threads I was using is 16. I have a 16 core CPU on this development machine. I think that's fine, but actually if we divide this by 128, then we're going to get 0. This number makes a lot of sense in the crawler, where I have like 500 threads or something. It doesn't make sense here. Yeah, so we create the pool, and then at the end we want to shut down and wait. And we can remove this pipe. And what do we do? Well, we need a semaphore as well. And is this supposed to be? Yeah, it's supposed to be max pool size. That's fine. Actually, we do this, and then we do a try catch. No, actually, we don't need a catch exception. It will escape anyway. We acquire the semaphore, and then in this part we need we insert this into the pool, and please keep your pants on, Copilot. I don't want this long piece of code just yet. Right, and then we put the logic in here. Like so. Control key is nice, and so, and then we should be able to just finalize this piece by pasting in this here, like so. Yes, I do have an ID here. Like so, and then we finish the job. Compile size, and then we have this heartbeat thing. Cool, and then we have a catch for IOexception. Like so. I think this should actually work. Then we can delete this parallel pipe construction. Okay. Is there any reason why this wouldn't work? Actually, I want to get rid of this var things. It makes the code quite hard to follow. Yeah. Well, let's just actually I don't want clean. It's going to take forever if I do a clean. What is going on here? weird. Oh yeah, it's just dumping some logs on me. This is where I wanted to start it, because this terminal is nicer. Right, let's check. We go to the control service, and then we can go. This operator screw is something I started working on like 2 weeks ago, so it's incredibly crude. It used to be I did all of this manually by scripts, but it's becoming so much work, so I built this instead. I want to load some data. I'll just try with the Marginalia website first. Okay, it's over counting, I think, but it's a lot faster. That's nice. That's nice indeed. And I apologize for this bright wall of whiteness here. I should get some like CSS going, so I have to look away for a while anyway. Let's try loading the blog set instead, which is basically a bunch of blogs from a thread in Hacker News a while back. Oh, actually, I'm running the loader. I shouldn't be running the loader. I should be running the crawler. Let's kill this and kill this. And this piece is actually kind of cool. I'm going to talk about it in detail later, but it's doing very cool things using state machines and a message queue. Okay, so we are processing. It's still very quick. Where is it? Why am I still getting this converter process thing? Hasn't. Oh yeah. I'm actually running the old code. That's stupid. I need to rebuild the Docker images and rebuild dist as well to get new artifacts. Otherwise, it's going to be running the old code. I was so happy that the code was faster, and it's the same code. That's it. It's the classic optimization trap. You're like, yeah, I've made this code 10 times faster, and then it turns out that you're running the original function. And I don't want to start Firefox. I want to open this one, and we can. Oh, it's still starting up. That's tricky. Here we are. Let's go to crawl data, and then we go to only Marginalia, and then we process. Is it doing anything? Yeah, it's still quick. I'm a bit concerned there might be there might be some resource contention when I'm doing this for real, because you're going to have a lot of rights, and the storage area I have for processed data is it's a slow NAS drive, and this is really struggling. I think I may need to tweak my settings a bit. Because OBS is kind of choking while I'm doing this. Maybe it's just a preview. We'll find out later. If this is horribly choppy, I'll cut it out. Let's look at the memory usage. This is for the converter. Actually, this is really low. Wow, this is so low. It's like almost halved. Used to be 7 gigabytes or so. That's cool. That's really cool. I'm not sure why it's reduced though, because I haven't actually done the optimization for memory yet. But maybe this is reducing the queue size or something. Could be, or it's just having an easier time with the garbage collection or something. I don't actually know. That's weird. Is the stream flowing again? If the stream cut out for a moment, the CPU from the processing actually, it basically ran 100% of every core, and for some reason hardware encoding doesn't work today. I'm not quite sure why. It worked yesterday. So if the stream cut out for a moment, then the reason is because I edited out some really choppy video and audio. If it didn't, then that's great, and maybe it was just the OBS preview that was acting up. Who knows? I'll have to check that later. Right, and we actually don't need to look at this because it's not related to what we're doing now. It's running this like finite state machine here and doing a bunch of other stuff automatically. So we can actually minimize this so I'm not blinded by this white screen. Right, where are we? Yeah, so we removed the parallel pipe thing, and now it's actually not used anywhere in the code, so we can actually go and delete that in a moment. But what I want to fix first is this thing. If I pass in like a consumer of instruction instead of populating a list this way. Let's see how that works. And it's going to be some plumbing, but I think it's fine. And then we just pass in this thing, because nothing is actually iterating over this or anything like that. So we can actually this is going to be some work, but no, sorry. Right. And this is going to be quite some work, but that's fine. That's just how this line of work is. Sometimes you just need to do repetitive tasks like this. Okay, that's 2 down, and then we actually, I think we just do this. so. And a lot of these classes are very small and very isolated, but that's for a good reason. It makes them very easy to consider in isolation. And for this type of logic, that's actually a nice thing. You don't always want that. Like I'm not telling anyone to be an Uncle Bob zealot. Sometimes you do want these more big and complicated classes, but in this case, this type of workflow, it's actually what was going to say there? It's actually very helpful. Right, so now we need to change this, and like as a first step, we can just do this instead, and that should still work, or shouldn't it? Oh, yeah. We need to do this. That should still work. The next step, possibly the final step, is to modify this instruction writer. And it needs to return something that represents the writing of one of these files. And how do we do this? We'll worry about the name of the class in a moment. For now, it's just we're putting together something. And we want an output stream writer. Paste. Right, and this needs to be auto-closable as well, so we finalize the file. These Z standard streams, they're really finicky about closing them. If you don't, then the data gets corrupted, so that's super important. Actually, we can do this. Like so. All right. Right. And there's actually we're doing a bunch of different things here. As I mentioned earlier, these instructions, they're doing a visitor pattern, and it turns out you can actually have it visit different classes, and this is a logger that when processed with error thing shows up, then it actually prints it out to a special file that we can look at later. So we need to apply it here. And then we can just do this. Let's actually we change it to so that it matches the old code. possibly there's an IO exception here, but we don't want to force the compiler code to deal with that, so we just try catch it. And log it, and then we can do this. The actual data is bastardized tagged version of JSON that's said standard compressed. Right. And I don't want this to be static, because it needs access to this log method. And then I want to have like a and it takes this ID string. This is, if I remember correctly, it's like a string hash of the domain name or something like that. Like so. Actually, I think I need to refactor this a bit later as well, but for now, this should do. Why are we returning the... All right, we need to need to do this as well, because we're creating a lot of logs doing this, and it's because and I don't mean like round logs, log4j logs. I mean actual log files that are used for recovery and so on, and this is for one of those. We actually need to be able to figure out later where which domain ends up in which file and so on, and it's the way it's currently done. It's just a deep nested directory structure, and then later on the plan is to move to something like Parquet or something, maybe just SQLite or whatever. But right now we have like a very large directory structure with files that are sed compressed, not quite JSON. So instruction writer, create instruction for domain, right. Actually, this is going to be a bit nasty because we need nested try catch statements here, because we want this auto-closable functionality to work. Right. Actually, we can do this. This should be set. And we can move this logic in here. There are cases where these instructions don't actually do anything. Some of them have like lists in them of things to be inserted, but they may be empty, and in that case there's no point to writing them down, which is why we have that. Let's see, we go here, and this should be an IO exception. Then we don't get this complaint, and we can remove that, and that's fine. We don't need that. Actually, right. We need this for the log as well. Right. Should we try this? This accept method isn't used anywhere anymore, so we can throw that away. Right. Summarizing interpreter. We don't need that either, right? It's not used anywhere. Let's just delete that. We're having problems? No. Yes. Accept. Right. Right. Where was I? Okay. Let's just rebuild it, I guess. There's probably a bunch of tests that are broken now. For some reason, I don't know if it's Gradle or IntelliJ. Some of them, some piece of logic isn't great at discovering what to rebuild all the time. And actually clean compiles are taking kind of forever nowadays. So yeah, it's not great. Let's just rebuild it and redeploy it and see what happens. Can run the tests later. I think this instruction writer should be like an instruction writer factor or something. That's a good point. This can be fine now. Okay, let's try it again. Seems to have worked for the Marginalia website. No exceptions here. Great, so let's try the blogs set. I actually think I removed some logging. I didn't want to do that. So where did that vanish? Show diff. Okay, not in here. All right, this summarizing interpreter. I didn't want to remove that. I actually just wanted to have it run. So I just do this, put it in the domain rater instead. Need to modify it so it doesn't require a list. And then we do this on close instead. I think this is basically the same. We'll let this thing finish first before we rebuild. Yes, I think this should work, and this can actually be fine on private. We don't need this. Great, and we can let's do this, and then we great. And this is package private. That's fine. Is there some comments I want to add to this? I mean, it's super straightforward, so I don't think so. Right, so this is finished. Let's try again. I'm actually have a look at the message queue, and I don't think the GUI is quite capable enough to do what I want to do. So we'll open a more competent SQL tool. Actually, it's not up yet, I guess. Why is it not up yet? Should be up. Yeah, says it's up. Just wasn't connected for some reason. Whatever. And what is the recipient inbox for this guy? The converter monitor. FSM converter monitor. I'm kind of curious to see basically how long it takes. But we'll play with that in a moment. Let's load this blog set again, yet again even. What I was preparing was to see if I could figure out a neat way of basically figuring out how long the runtime of these processes are, because my hope is to be a bit quicker now that I've optimized the code a bit. How is the CPU? It's really struggling. Hope the stream is all right. That doesn't look. Oh yeah, actually that's entirely fine. There was some problem when I was crawling this actually with the specifications of what to crawl, so it actually contained the same domain name like 4 times, and it was crawling the same domain at the same time and writing to the same file, and then it's writing said standard compressed JSON again. So the file, so I got like a couple of references to the same file that's garbled as hell, so it's creating these exceptions, and that's entirely a problem with the crawler, and on the receiving end it's fine. So let's see, this took 2 minutes. That was quicker. That was when I was running it for my own website, and this is also 2 minutes, and this is also my personal website. 451 a minute. Like so. Function equals run. Yeah, so I don't know if it's actually gotten all that much faster, but I guess that's still fine. What we were mostly interested in is reducing the RAM. And I think we've actually done that. And now we can go to the ParallelPipe class and actually delete that, because it's not something that we want to use. It's not a good way of doing this. Actually, we can kill this. And there was a bunch of problems with this ParallelPipe class. The way it was implemented was by basically overriding a base class. So you got these like additional methods that were like on receive and on load or something like that. And the problem with that is that they were like semi-externally visible, so actually using it was confusing because you needed to know that you should invoke the accept method and not on receive, which isn't very clear. And sure, it could have been rebuilt in some way where it took function references or something like that, but I mean, this is not a civilized way of solving the problem, so let's do it the proper way instead. Not that I don't think one shouldn't experiment. Experimentation is great; it's how we learn. But we shouldn't get married to our experiments and refuse to recognize that this wasn't a very good thing. Yeah. Was there anything else on this list? So memory usage has been at least theoretically reduced, and the ParallelPipe is dead, and this is the way we're doing it now. So that's cool. I'm going to run some tests, but that's not very interesting content. So if you've made it through the entire video and my ramblings, thanks. Maybe I'll upload more videos later. But yeah, this is fun to make, so I hope it's at least a bit enjoyable to watch as well. I know I like this sort of a video, so maybe another dozen people will like it too. That's cool. But I'm not going to torture you with having to watch a full clean and rebuild and git message authoring and so on. That's a bit tedious, I find. So I will leave you